angle of elevation and angle of depression. Let us understand the concept of the angle of elevation and angle of depression with the help of an example. So we have a person, and this person is standing at the shore. So there are two objects. There's a bird over here. The bird is flying, okay, and there is a fish inside the water. So there are two objects, we can say. So we have the first object as a bird flying at particular height, and we have got a second object is a fish which is inside the pond. Now this person, so this is the person who's standing on the shore. If he is looking at the bird at particular instant, let us say, so when he looks at the bird, when this person is looking at this object, that is a bird, he is making certain angle with the horizontal, something like this. This is the horizontal, friends, okay. So when person looks at the bird, his line of sight, this is the line of sight, you can say. So when the person is looking at the bird like this, so his line of sight is making certain angle with the horizontal, okay. So this angle is referred as angle of elevation. So elevation means when the angle is made by the line of sight above the horizontal line. When the line of sight is above the horizontal line, this is the horizontal line, friends, okay. So the line of sight is above the horizontal line. So that angle is called as what? Angle of elevation. If I write definition, angle of elevation is the angle made by line of sight above. So whenever it is elevation, we say above. So angle made by line of sight above the horizontal line. Okay. So whenever line of sight is making an angle above the horizontal line, that angle is called as angle of elevation. So if the person is looking at this particular bird at particular instant, he has to make a line of sight over the horizontal line, then only he can see the bird, because the bird is flying over the horizontal line or above the horizontal line, okay. But in the next case, when I write, so if the person wants to see this particular fish, we can say, so his line of sight will be something like this, okay. So in this particular case, the line of sight is going to be below the horizontal line. So this is the line of sight. So here if you see in the second example, friends, the line of sight is below the horizontal line. So this is called as what? Angle of depression. Very simple. So angle of elevation is above the horizontal line and angle of depression is below the horizontal line. So I can define angle of depression also. Angle of depression is the angle made by line of sight below the horizontal. Always remember, angle of elevation is above the horizontal line and angle of depression is below the horizontal line, okay. So this is a simple example to understand the concept of angle of elevation and angle of depression. So these are simple example to understand angle of elevation and angle of depression. So now we will take one example to understand the concept clearly and how it is applied. So we have a very simple example, friends. If you see the question here, a person is standing at a distance of 80 meters from a church, looking at its top. The angle of elevation is 45 degree. Find the height of the church. So let's understand the question first. So we have got a church here. We can say this is a church, okay, and a person standing at a distance of 80 meters from a church. So I'll draw a person over here, but the person will be very small. So I'll just take a small point like this and I'll say there's a person standing here. So here is a person, this point, okay. Let's say the point A represents the person, and this person is 80 meters from the church, okay. So distance between the person and the church is, let us say, 80 meters. I'll take center of this church like this, and from here I'll draw the distance. So this distance is given as 80 meters like that, and the person is looking at its top. So person is looking at its top, so we can say the line of sight will be something like this. He's looking at the top of the church, and the angle of elevation, so this is going to be the horizontal line, friends. So this line indicates the horizontal line. This angle is angle of elevation, okay. So they have given the angle of elevation as 45 degrees, so this angle is going to be 45 degrees. So you, as we know the definition, the angle above the horizontal line is called as angle of elevation. So here we have angle of elevation as 45 degrees. The person is standing at 80 meters, so this distance is 80 meters we got. Find the height of church. So we need to find this height. So we need to find this height. This is the height of the church. So we need to find this height of the church. Let me call this as h. So we have to find this. Okay. So in this problem, everything is very simple. So we got all the information here. So to solve such problem, we need the trigonometric ratios first. So we have already defined trigonometric ratios for a right angle triangle. This is theta. This is called as adjacent side. This is called as opposite side. And this is called as hypotenuse. Okay. So there are few trigonometric ratios we require. Like we have sine theta, which is opposite side divided by hypotenuse. We need another trigonometric ratio cos theta, which is adjacent side divided by hypotenuse. And the third one is tan theta we require, friends, which is opposite side divided by adjacent side. So in order to solve problem based on angle of elevation and angle of depression, at least these three trigonometric ratios we must be knowing. Okay. So I have just given you in short three trigonometric ratios. So now if you see this particular problem, friends, if this point is point A, let me call this point as point B and this point as point C. And here this angle is going to be 90 degree because this line is going to be vertical, line BC is vertical and this is horizontal. This is going to be 90. So in triangle ACB, we can say angle C is 90 degree. So now we have to find the height. Height means we have to find this particular side. BC is question mark. Okay. So we have to find the height BC. So now if you see triangle ACB, this will be called as adjacent side because this is the angle I am taking. So this is the adjacent side. The BC is the opposite side. So adjacent and opposite are involved in the tan theta, we can say. Here you can see tan theta, where opposite is involved, adjacent is involved, and the angle tan theta is involved. Okay. So I can use tan theta, and then with the help of this particular ratio, you can easily find out the BC. So in triangle ACB, angle C is 90 degrees. Okay. Therefore, if I write tan of this angle, let me call this angle as angle theta. So tan theta will be opposite side, that is BC, divided by adjacent side, that is AC. So if I simplify this, this is going to be theta is 45 degree. So it is tan 45. BC is not known to us. We have to find BC, friends. And the AC value is 80 meters. So it is given. Please remember, tan 45 is 1. So I can put the value here. Therefore, you will get 1 equals BC by 80. So if I simplify this, from here I'll get BC equals 80 meters. Okay. So whatever is the distance between A and C, the same distance will come here, that is going to be 80 meters. So answer would be very simple. Therefore, the height of church, that is BC, will be equal to 80 meters. Straightforward. Therefore, height of church is going to be 80 meters. We will see one more example to understand the concept. So friends, we have a question here. A boy standing at a distance of 48 meters from a building observes the top of the building and makes an angle of elevation 30 degrees. Find the height of the building. This is again the similar question. So a boy standing at a distance of 48 meters from the building. Okay, so there's a boy here, friends. Let's say he's a boy. Again, I am showing boy by a simple point because the height of the boy is insignificant. So this is a boy, let's say, and this is the building. So this boy is 48 meters from the building. Okay. So this distance is 48 meters and the boy is making the angle of elevation of 30 degree. So boy is observing the top of the building. So the line of sight will be like this. So this is the top of the building and the boy is observing the top of the building. So boy is making the angle of elevation. This is the angle of elevation, let's say theta, which is equal to 30 degrees. Okay. As the definition says, the angle made above the horizontal line, this is the horizontal, friends. So angle above the horizontal is the angle of elevation, which is I am calling theta. Okay. So the angle of elevation given is 30 degree. So we have to find the height of the building. This is height of the building we have to find. Now I will give the naming. So let's say this point is point A, this point is point B, and the top is point C. Okay. This is going to be 90 degrees. So we have to find BC. So again, in this particular case, I can use the trigonometric ratio tan theta. Okay. So I am going to consider triangle ABC such that angle B, this angle is 90 degree, friends. So we have the adjacent side. The opposite side is not given to us. So I can use tan theta because in tan theta is the ratio of opposite side to the adjacent side. Okay. An angle is given to us. Therefore, tan theta will be equal to opposite side divided by adjacent side. So here the opposite side is this side, which is BC, and adjacent side is AB here. So now we'll get the theta is the angle of elevation, so tan 30 degree equals BC is not known. We have to find the value of BC, friends, because height of the building we have to calculate, and the AB is given as 48 meters. Tan 30 is, the value of tan 30 is 1 upon root 3. Okay, these values should be known to you. There are few standard trigonometric ratios, that value should be known to us. So tan 30 is 1 upon root 3, and the BC divided by 48. So if you simplify this, you'll get BC equals 48 divided by root 3. Therefore, the height of the building, which is basically BC, is 48 divided by root 3. So this way you can easily find out the height of the building by using trigonometric ratio if the angle of elevation is given to you. Friends, we shall see one more example based on angle of elevation and angle of depression. We have an example from the top of a lighthouse. An observer looking at the ship makes an angle of depression 60 degrees. Okay, so we'll try to draw the lighthouse first. Okay friends, so this is the lighthouse, you can say. From the top of the lighthouse, an observer, so let's say observer is sitting at the top somewhere here. So from the top of the lighthouse, the observer looking at the ship makes angle of depression 60 degrees. Okay, so the observer is looking at the ship from the top of the lighthouse, we can say like this. So this is the line of sight. So this is the ship, we can say. So from the top, he is looking at the ship, something like this. So this is line of sight. So an observer looking at the ship makes angle of depression of 60 degrees. Okay, so there will be horizontal line like this, and with respect to the horizontal line, there will be angle of depression. So as per the definition of angle of depression, the angle below the horizontal line, this is the horizontal line, friends. So this angle is below the horizontal line, so this is the angle of depression. This is given as theta equal to 60 degree. Let me call it as theta. Okay, so if the height of the lighthouse is 90 meters, so this height is given to us, so this height is given as 90 meters, friends, 90 meters. Okay, then find how far the ship is from the lighthouse. So from the bottom of the lighthouse, what is the distance of the ship, you can say. So let me call this point as point A, this bottommost point as point B, friends. I can just draw a vertical dotted line just to show. So this point is point B, and here this point let me call as point C. There is a triangle ABC where angle B is going to be 90 degree, friends. This angle is going to be 90 degree. Okay, so we have to find the BC. Okay, the height is given to us, that is 90 meters, and this angle is 60 degree. So by simple geometry, we can say this angle is also going to be 60 degree. Okay, these are the adjacent angles. Okay, so this, since this angle is 60 degree, the angle of depression is 60 degree, this angle is also going to be 60 degree. So we have to find here how far the ship is from the lighthouse. That means we have to find the length CB. Length CB we have to calculate. Okay, so considering triangle ABC, so we shall consider a triangle and we will apply trigonometric ratio, that is tan theta or tan of the angle. Okay, so considering triangle ABC, angle B equals 90 degrees. Therefore tan theta, I am considering this angle as theta, which is same as angle of depression, friends. So that is equal to opposite side, that is AB, divided by adjacent side, that is CB. Therefore you will get tan 60 degrees equals AB. AB is given as 90 meters, and then CB we have to calculate. So from here the CB is going to be 90 divided by tan 60. So 90 divided by tan 60. Tan 60 is, friends, root 3. Okay, so from here you get, therefore the ship is, so we got this distance CB as 90 by root 3 meters. Okay, so we can say therefore ship is at distance 90 divided by root 3 meters from the lighthouse. Very simple. So in this kind of problem, sometimes they will ask you this distance, or sometimes they will ask you this distance. Okay, mostly these, either this one or this one will be missing in the question. So we can simply use the tan theta ratio, and then we can easily find out the value of the missing quantity, maybe this distance or this distance. Okay, friends, we have one more example based on angle of elevation and angle of depression. So let's read the question first. Two buildings are facing each other on a road of width 12 meters. From the top of the first building, which is 10 meter high, the angle of elevation of the top of the second building is found to be 60 degrees. What is the height of second building? So what they have mentioned is, we have got two buildings which are facing each other, and in between there is a road having width 12 meters. Okay, so from the top of the first building, which is 10 meter height, the angle of elevation of top of the second building, means the first building is smaller compared to the second building because the first building is having angle of elevation. Okay, so let me show you the entire condition. Okay, so you can see here we have got two buildings. This is the first building, this is second building, you can say. So two buildings are facing each other on the road of the width 12 meters. So the distance between these two buildings are, if I say this is going to be 12 meters. Okay, from the top of the first building, which is 10 meter high, so first building, which is this one, let's say it is 10 meter high, the angle of elevation of the top of second building, so this is the top of second building, we can say. So from first building, the top of second building is making some angle of elevation. So how to make angle of elevation? We know that like this, and this is going to be the horizontal line, friends. Okay, so with horizontal, whatever angle is made, this is the angle of elevation. So this is making angle of elevation how much? 60 degrees. Okay, like this. So top of the first building is making the angle of elevation with the top of second building like this. Okay, so the angle of elevation is given as 60 degree. Okay, so we have to find the height of the second building. Now if I draw the horizontal line like this, so this much height is going to be 10 meters, as we know. Okay, and above than that, above the horizontal line here, this height we don't know, so I am going to call this as h. Simple. So in this case, if I can find out the value of h, I will get the height of second building also. So this is very simple. The first building is 10 meter high and it is making angle of elevation. So angle of elevation means angle above the horizontal line. This is the horizontal, friends. This is the horizontal. Okay, so since this is the horizontal, the angle of elevation is going to be above the horizontal line, so it is 60 degrees they have mentioned here. The height of this building is 10 meters, so if I draw horizontal from here, that will be 10 meters, and above this height 10 meters, we have to find what is the height of the second building. So if I know this h, I can find out the height of second building also. So I think the most of points are clear. So we are able to draw the figure with the help of the given condition in the question. Okay, now let us name these points. So if I name this point as point A, that is top of first building, this point as point B, that is top of second building, and this point as point C. So it is very much clear that this is horizontal, this line is horizontal AC, so this is going to be 90 degrees. Now this is 12 meters, so this is also going to be 12 meters, there is no doubt. So if you see the triangle ABC, in this angle C is 90 degree, so we know this distance, so we need to find only BC. In solution, considering triangle ACB or ABC, angle C is going to be 90 degree. So I am going to use trigonometric ratios here. This angle I am calling as theta, which is angle of elevation. So by tan theta we can say that tan theta is the opposite side divided by adjacent side, that is BC, divided by AC. So if I simplify, tan 60 degrees, friends, they have already given, and that is equal to BC, that is h we have to find, and AC is given as 12. Therefore the value of h is going to be 12 into tan 60. Tan 60 is root 3, therefore h is going to be 12 times root 3. Okay, so therefore height of second building will be 10, which is this much, plus h, and that is equal to 10 plus 12 root 3 meters. So this you can calculate, that's very simple. So this is the procedure how we can easily find out the height of the second building since the angle of elevation is given to us. Now we shall see one more example. Now if you read the question here, two poles of height 18 meters and 7 meters are erected on the ground. So we have got two poles, one is having height 18 meters and the second one is having 7 meters are erected on the ground. The length of the wire fastened at their tops is 22 meters. So their tops are connected with the help of a wire and the length of the wire is 22 meters. Find the angle made by the wire with the horizontal. So let's see how it looks like. So friends, you can see here we got two poles. So friends, you can see here we have got two poles. This is the pole, first pole, which is having height 7 meters, and this is second pole having height 18 meters, let's say, and their tops are connected with the help of a wire, something like this. The length of this wire is given as 22 meters. Let me call this point as point A and this point as point B. So we have to find the angle made by the wire with the horizontal. So if I draw this line, this is the horizontal line, so we have to calculate this angle, that is theta. So we have to find this angle. This is basically angle of elevation. This is, we have to calculate the value of angle of elevation. Okay, this is B, this is A, let me call this as C. So let me call this point as point C. Now if you look at the diagram, it is very clear that this distance from here to here is going to be 18 minus 7. Right? From geometry itself, it is clear. This is going to be 18 minus 7, and that is equal to 11 meters. So we have got a triangle here. So in this triangle, this side, that is BC, is given to us, and this side, that is AB, is given to us. Angle is not known to us. Okay, fine. So this is basically, if I take this as this angle in a right angle triangle, friends, this side is called as opposite side, and this side is called as hypotenuse, and this angle is theta, for instance. So we have the opposite side with us, we have the hypotenuse, you can see here. So opposite and hypotenuse, we can get a ratio which is called as sine theta. The sine theta is basically opposite side divided by hypotenuse. Okay, so with the help of sine theta ratio, we can easily find out the angle theta. Since we have the opposite side and we have hypotenuse, so ratio is known to us, so we can find out the angle theta. So I'll show you how to find out this. So considering triangle ACB, angle C is 90 degrees. Therefore, sine, this angle I am taking theta, friends. This angle is theta. Okay. So sine theta is nothing but opposite side divided by hypotenuse. So opposite side is nothing but BC. Because BC is known to us, so we can have only one unknown. So here this is known to us, this is also known to us, only sine theta is unknown, so we can calculate. Okay. So always, whenever you take a trigonometric ratio, you make sure that at least two values are known to you. Okay. One unknown can be easily calculated. Okay. So sine theta equal to BC divided by, that is AB. AB is the hypotenuse here. So therefore, sine theta is going to be, BC is 11 and hypotenuse is 22, friends. So that will be 1 by 2. So it means we got sine theta equals 1 by 2. But we know that sine 30 is 1 by 2. Okay. This is the basic trigonometric ratio. Sine 30 is 1 by 2, friends. So therefore we can say, therefore theta equal to what? Therefore theta equal to 30 degrees. Okay. So the angle made by wire with the horizontal is going to be 30 degrees. Okay. Straightforward. So this way we can easily find out the unknown angles if you know any two sides of the triangle. Okay.